So now let's take a detailed look at the nature of sound and in what form it propagates through the matter, and can it propagate through vacuum or does it require a medium? Let's take a detailed look at these aspects. Sound is associated with our sense of hearing. We hear the sounds with the help of our ears, and it is the physical disturbances that travel into the ear which the brain recognizes them as sounds. So the physical disturbances travel in the air as longitudinal waves. There are three important aspects for a sound to be heard: a vibrating object, which is the source, and a medium where the disturbances caused by this vibrating object propagate through the medium, and obviously a receiver such as an ear or a microphone for that disturbances to be registered as sound. Now let's first examine the sources of sound. Sound can be produced from varieties of sources. It could be either from the musical instruments, or beating the drums, clapping the hands, or even the waves in the ocean. They create the sound. The primary aspect in all these sources is the vibrations. So one such object out here, which is the source of sound, that is represented here, is called as a tuning fork. The tuning fork typically looks like this, having two tongs that are vibrating, and the vibrations of these tongs produces the sound. The second important aspect is the medium through which the sound travels. So when such an oscillating object such as a tuning fork oscillates, what it does is it immediately compresses the air particles that are in touch with the tongue, and those compressions are the ones that travel through, causing the eardrum in the ear to vibrate and register the physical sensations as sound. So again, a very important point to note out here is that it is not the particles that are traveling, but rather it is the disturbance that is traveling through the air as a medium in the form of longitudinal waves. So as we have observed, in waves and vibrations, the longitudinal waves, as we have already noted, the particles in itself just exhibit an oscillatory motion or a vibratory motion. They themselves would not travel till the end of the medium. Rather, they just oscillate to and fro by their mean or equilibrium positions. So it is the same case with the air particles as well when the sound is produced. The air particles also exhibit the same kind of elasticity when the sound is propagating through the air, and the air particles themselves do not travel till the end of the medium. Rather, it is the vibrations of the air particles which translates to a disturbance as a compression, and that compression is the one that is going to travel. So to exemplify the nature of vibrations of the air particles, here we have two of the particles colored in red, and what we can observe is that as the wave compression passes through it, it doesn't flow along, but rather it just vibrates to and fro about its mean position. So this is how the sound propagates through the vibrations of the air particles. And the air particles exhibit such a kind of an elasticity when the sound is propagating through it.